Hi guys, this is Calc video 6-8 for Tuesday the 14th. Happy Valentine's Day. And there's no homework associated with it. I'm going to go faster than I have been the past two videos. I'm making all of them in the same sitting and it's the morning and I'm tired. So I'm going to try to push the pace a little bit. And if you have to go slower, just pause the video or slow it down. Okay, so region R is bounded by the graph of this and the x-axis. Find the area. Okay, so first I'm going to draw this. Okay. Okay, so right now I'm just drawing the region. This is an upside down parabola and the y-intercept is at 9. Okay, so bounded by this graph and the x-axis. So here are the vertices of my region. So here is the region right there. And this is 3, 0, negative 3, 0, and 0, 9. So we want to find the area of this region R. So you have to ask yourself, am I going to do top minus bottom because it passes the vertical line test, or am I going to do right minus left because it passes the horizontal line test? It is not actually passing the horizontal line test. Every horizontal line is intersecting this graph twice. Okay, so it doesn't pass that, so we have to do top minus bottom, so everything in terms of x. So for number 1, I'm doing the integral. So everything in terms of x, so from x equals negative 3 to 3 dx, and then inside here goes top minus bottom. Okay, so top minus bottom. So top is 9 minus x squared, bottom is 0. So 9 minus x squared. All right, and then I just plugged it in my calculator earlier and I got 36. Okay, so that's number 1. We're not going to do number 2. Okay, we're going to do number 3 instead. So if R, so this shaded area, is revolved around this line, x equals 4, find the volume of the resulting solid. Okay, so we're going to revolve around the line x equals 4. Okay, so x equals 4. It's going to be like over here. Okay, so that's x equals 4. And we are revolving the region around this line here. So this is different than before. We're not given an axis to revolve around. We're given a line to revolve around. And anytime this happens, it'll either be a vertical line or a horizontal line. So we'll be revolving around that. Maybe first, guys, I'll do the, I'll draw the cross section on here and then I'll go to the chart. So whenever you're drawing the cross section on your picture, so this is the axis of revolution. That's what this is called. So you go to the axis of revolution, you find a center of a cross section. So the centers of all cross sections are going to be somewhere on this axis. So I'll say, like, let's do right here. So that'll be the center. Okay. Between the center and the region, there is some empty space. Okay, so that will be our lowercase r. So we're going to have a washer instead of a disk. And then from the center to the end of the region, this will be capital R right there. Okay, now when we rotate around, so this is going to be empty. Okay, so I'll have that empty space right there. And then this one is rotated around. All right, so there we have a washer. Okay, if there's empty space between the center and the region, you'll have a washer. If there's no empty space between the center and the region that you're revolving, then you will have a disk. Okay, so now I can say revolves around cross section and the cross-section's area. So it's revolving around x equals 4. Now this is going to be a little different than before, guys. So x equals 4, well, how do we know what we want things in terms of? The line x equals 4, this is like the y-axis because it's vertical, okay? So even though it's the line x equals 4, it's like the y-axis because it's a vertical line. So everything's going to be in terms of y. So that's how you'd figure it out. If it was a horizontal line that we were revolving around, that would be like the x-axis. So everything would be in terms of x. So this is like the y-axis. So everything in terms of y. Now for the cross-section. Okay, there's the center. Okay, so center, little r, big R. Okay, so I need big R and I need little r. Okay, so these are horizontal lengths, so right minus left. So for big R, this is big R right here. So right minus left, right minus left. So right is 4 and left, oh, okay, I gotta slow down. This is like the y-axis, so I need everything in terms of y. Everything in terms of y means that you've got to solve for x. So if I go back up here, okay, so this was y equals 9 minus x squared. So you got to solve for x. X equals, subtract 9, divide by 1, take the square root, plus or minus radical 9, plus or minus radical 9 minus y. Okay, so back to our problem. So this side, so I've got two sides. This is messy. I've got two sides of this parabola. One side is the positive expression, the other side is the negative expression. So this side, this is where the x values are negative. So this is x equals negative square root of 9 minus y. And on this side, x equals positive square root of 9 minus y. Okay, so back to this. So right minus left is 4 minus this one. So 4 minus negative 9 minus y. So 4 minus negative radical 9 minus y. So this is 4 plus radical 9 minus y. Okay, so that's big R. And then little r, again, right minus left, right minus left, right minus left. So 4 minus this positive 1. So 4 minus radical 9 minus y. So now that we've got the radii, we could do the area. So area is pi big R squared. So 4 plus radical 9 minus y squared minus little r squared. 4 minus. Okay, and now to find the volume, we just have to take the, do the integral. Oh, I'm going to go below. So it's the integral from y equals what? So the lowest y value is 0, and the highest y value is 9. And then inside of here I've got pi. I'm going to use brackets there because there's so many parentheses. 4 plus radical 9 minus y squared minus 4 minus radical 9 minus y squared. Close parentheses, dy. I already did this in my calculator. It's 904.779. Okay, now we're going to do two more. Okay, so this one. Sketch the region R bounded by the given curves and lines. Then find the volume of the solid generated by revolving R around the given axis. So example number 2. We've got this curve, that curve, and we're revolving around that axis, which happens to be one of the curves. So I'm going to draw this picture. Okay, so drawing the picture. Okay, so y equals 3 minus x squared. Looks like this. And then y equals -1. That's going to be 1 unit below the x-axis. Y equals -1. Okay, so there's the vertices. Okay, so there's the region. And I'll do the chart first. Okay, so revolves around cross section area. It's revolving around y equals -1, but this is like the x-axis, okay, because it's a horizontal line. Think of it as like just the x-axis shifted down. So everything needs to be in terms of x. Now for the cross section, so we're revolving around this line. I find a spot on my line that's going to be the center of one cross section. So like right here. And then I draw, guys, there's no empty space. So this is going to be a disc, not a washer. Okay, so I draw a line from the center. So that'll be the center of my cross section to the end of the region. Okay, and then this will be the radius right there. All right, there was no empty space between the center of rotation and the region, so that's how I know that it's a disc and not a washer. So it's gonna look like this. Okay, so it's gonna look just like that. So the cross section, that'll be the center. There's the radius. Okay, and this is a vertical distance, so the radius will be top minus bottom. So top minus bottom, so 3 minus x squared minus -1. 3 minus x squared minus -1. So the radius is 4 minus x squared. So the area is just regular pi r squared. So regular pi 4 minus x squared squared. And now for the volume, I do the integral. So the volume is going to be the integral, everything is in terms of x. So x equals, oh darn, I should have found these points. I actually did find them earlier. So this is 0, 3. This is -2, -1. And this one is 2, -1. Okay, so from x equals -2 to 2. And then what goes, the input of this is going to be the area of the cross sections. And I used my calculator earlier and I got 107.233. Okay guys, one more. Last example of the unit. Okay, so example number 3. Same directions. We've got y equals this parabola, y equals 0, which is the x-axis, and y equals -20 is the axis that we're going to revolve around. Okay, so let me draw this picture. Okay, so the parabola actually looks like this. It's going to go up through here. Okay, and I used my calculator earlier to figure that out. So that's what the parabola looks like. So my region is formed by this parabola and y equals 0, which is another name for the x-axis. So right there, there is my region. And then the axis I'm revolving around, the axis of revolution, is this horizontal line. So y equals -20, so it's like way down here. Actually, let me, okay, so this is the axis that I'm revolving around, and it's y equals -20. Okay, so we're going to revolve around that axis right there. Okay, I'll draw the cross section first. So here's my axis of revolution. I find a point on it that's going to represent the center of one cross section. So like right there. I want a point that is like either directly above or below the region. And so I'm going to draw a radius. So I want to go from the center of revolution to the end of the region. But in doing that, I'm going to have some empty space. So from the center to the beginning of the region, that's going to be the little radius. So we're going to have a washer. And then from the center to the end of the region, that will be capital R right there. Okay, so we're going to have a washer as a cross section. Okay, so I'm going to say revolves around, and then I need the cross section, and then I'll need its area. So we're revolving around y equals -20, but what is this like? This is a horizontal line, so this is like the x-axis. So everything needs to be in terms of x. Now for the cross section, I have a washer, so that'll be the center. This is the little radius. That's the big radius. Okay, so I need to represent the big radius and the little radius. These are vertical length, so top minus bottom. So for the big radius, top minus bottom, top minus bottom. So this top is the parabola, and then the bottom is -20. So it's going to be the parabola minus -20. So 16 minus 4x squared minus -20. So this will be, what is this? So this is going to be 20, right? 16x, that is. Okay, so this is 16x minus 4x squared plus 20. So that's big R. And then little r, top minus bottom, 0 minus -20. So little r is just 20. So the area is pi big R squared. So 16x minus 4x squared plus 20 squared minus little r squared. And then I just have to add them all up for the volume. So the volume is going to be the integral from, in terms of x's, okay, so all right, so I should figure out these points. That's definitely 0, 0. And then this one here, I did figure it out earlier, that's 4, 0. So the lowest x is 0, the highest x is 4, and then the area's got to go inside. So pi, and then 16x minus 4x squared plus 20 squared minus 20 squared dx, and then I plugged it in my calculator earlier and I got this 0.3799. Okay guys, that was the last video of the unit. We will have our test soon and I will see you soon. Bye-bye.